Have you ever heard of a ghost that exists in nature? One that vanishes as soon as it appears? Welcome to the enigma of Nitrogen-20. In the vast expanse of the universe, amidst the myriad of elements that form the very fabric of our existence, there resides an elusive character, a phantom if you will. This character is none other than Nitrogen-20, a peculiar isotope of one of the most abundant elements in our atmosphere. Isotopes, as you may know, are versions of elements with different numbers of neutrons. Nitrogen, by default, exists mostly as nitrogen-14 and nitrogen-15 in nature. They're like the well-behaved, predictable kids in the family. But then there's Nitrogen-20, the wild card, the unpredictable one. It's like the cousin who shows up at family gatherings, causes a stir, and disappears just as quickly as they appeared. Now, you may wonder, why is Nitrogen-20 so elusive? Why does it make such brief appearances before vanishing into thin air? Well, it's because it's radioactive, meaning it's unstable. It doesn't stick around for too long before it decays into something else, often oxygen-20. It's like a magician performing a trick, transforming before your very eyes. This fleeting existence gives Nitrogen-20 a sense of mystique. It's there and then it's not. It's like trying to catch a ghost. You know it's there, you've seen the effects, but trying to observe it directly, that's a whole different ballgame. It's this ephemeral nature that makes Nitrogen-20 so intriguing. Its existence is a flash, a momentary flicker in the vast timeline of the universe. Yet it has the power to captivate scientists, to draw them into its mystery. It's a puzzle waiting to be solved, a riddle begging to be unraveled. But what makes Nitrogen-20 so mysterious? It comes down to its fleeting existence. Nitrogen-20 is here one second, gone the next. Its ephemeral life is due to its unstable nucleus. Just as fleeting as a shadow, Nitrogen-20's existence is a scientific marvel, a paradox of the atomic world. To comprehend this, let's delve into the concept of nuclear stability and isotopes. Now, imagine an atomic nucleus as a tight-knit family, with protons and neutrons being the family members. In a stable nucleus, there's an even balance of protons and neutrons, all living harmoniously. Isotopes, on the other hand, are like alternative versions of this family. They have the same number of protons, which determines the element, but a different number of neutrons. However, not all families, or rather not all nuclei, are stable. Some are more like rebellious teenagers, constantly looking to break away from the norm. Nitrogen-20 is one such rebel. It is an isotope of nitrogen, with 7 protons and a whopping 13 neutrons. This imbalance makes it unstable, as the forces within the nucleus are not in harmony. So what happens when a nucleus is unstable? Well, it seeks stability, and it does so by shedding off its extra baggage, the extra neutrons. This process is known as radioactive decay. Nitrogen-20, with its excess baggage of neutrons, is quick to decay. It undergoes beta decay, where a neutron is converted into a proton, and an electron, known as a beta particle, is emitted. This transforms Nitrogen-20 into a completely different element, carbon-20, in a blink of an eye. This swift transformation, this transient existence, is what makes Nitrogen-20 so intriguing yet elusive. Scientists across the globe are striving to study it, to understand its behavior, its properties. But its ephemeral nature, its propensity to decay quickly into another element, presents a significant challenge. This transient behavior of Nitrogen-20 makes it extremely challenging to study. Yet, it is this very challenge that makes it a captivating subject, a mystery waiting to be unraveled in the realm of nuclear physics. Imagine trying to study a ghost. That's what scientists face with Nitrogen-20. Nitrogen-20, or N20 as it's often referred to, is elusive and difficult to study due to its incredibly fast decay rate. It's like trying to grasp a wisp of smoke, or as we've said, studying a ghost. N20 is an isotope of nitrogen, an unstable one at that. Its nucleus contains 7 protons and 13 neutrons, making it a bit of an oddball. This isotope is so unstable that it decays almost instantaneously, disappearing before you even know it was there. This rapid decay, known as beta decay, makes it incredibly challenging for scientists to study. So how does one study something that disappears almost as soon as it appears? It's a puzzle that has perplexed scientists for years. They've had to get creative to unravel the mysteries of Nitrogen-20. One method involves using particle accelerators to create high-energy beams of N20. These beams are then fired at a target, and scientists observe the resulting reactions. Another method includes the use of detectors specifically designed to catch the fleeting presence of N20. These detectors, often filled with a gas or liquid that reacts to N20, allow scientists to observe the telltale signs of its decay. It's a bit like using a thermal camera to detect the presence of a ghost. Even with these methods, studying N20 is still a daunting task. Its ghostly behavior makes it an enigma, a puzzle that scientists are still trying to solve. Each experiment, each observation only seems to deepen the mystery. Yet, this doesn't deter the scientific community. If anything, it only fuels their curiosity. Despite its elusive nature, Nitrogen-20 is not just a scientific curiosity. It holds a key role in the cosmos, playing a part in the creation of elements in stars. This makes it a topic of great interest in astrophysics. Despite these challenges, Nitrogen-20 holds a special place in science. It's a ghost that scientists are keen on unmasking, a puzzle they are determined to solve, because in the end, even the most elusive of ghosts can reveal secrets about our universe. Nitrogen, the 20th of May, be elusive, but it holds the key to some of the universe's most profound mysteries. Imagine holding a key to a lock that could open the door to the deepest secrets of the universe. Nitrogen-20, while under-researched, is just that key. Its unstable nature and ghost-like behavior make it a fascinating subject in the field of nuclear physics. It provides us with the unique opportunity to delve deeper into the understanding of nuclear forces. These forces are the glue that holds protons and neutrons together in an atomic nucleus. They are fundamental to the structure of the universe, yet we know so little about them. Nitrogen-20, with its peculiar properties, serves as a laboratory for studying these forces at their most extreme. But the significance of Nitrogen-20 doesn't stop at nuclear physics. It plays a starring role in stellar astrophysics as well. You see, stars are like cosmic factories, producing almost all of the elements on the periodic table, including Nitrogen-20. Understanding how Nitrogen-20 is created and behaves within stars helps us unravel the processes that cook up the elements. Imagine a star as a giant pressure cooker, with nuclear reactions at its core, producing a stew of elements. Nitrogen-20 is one of those ingredients that contribute to the recipe. By observing and studying it, we gain insight into the star's life cycle and the creation of heavier elements. Moreover, Nitrogen-20 is also a significant player in the field of medicine. Its unstable nature, which makes it a challenge in other fields, becomes an advantage here. Nitrogen-20's decay can be utilized in medical imaging techniques, helping doctors visualize the inner workings of the human body. So, in a nutshell, this elusive isotope, Nitrogen-20, is more than just a ghost in nature. It's a key player in the fields of physics, astrophysics, and medicine. So, Nitrogen-20, a ghost in nature, holds secrets that could answer fundamental questions about our universe. The story of Nitrogen-20 is far from over. We've journeyed through the unstable existence of Nitrogen-20, its ghostly behavior, and its significance in the universe. But as with any good mystery, the plot thickens and the intrigue deepens. The research into this elusive isotope is still very much alive and thriving, and the future prospects are nothing short of fascinating. Imagine, if you will, the world's most brilliant minds tirelessly working to unravel the enigma of Nitrogen-20. Their laboratories buzzing with activity, their minds abuzz with theories and hypotheses. Each discovery they make opens up a new avenue of exploration, a fresh perspective to consider. It's like a cosmic game of chess, where each move leads to a plethora of possibilities. But why, you might ask, is it so important to continue this research? Why not let Nitrogen-20 keep its secrets? Well, the answer lies in the potential impact of these findings. Understanding Nitrogen-20 could have profound implications for our understanding of the cosmos. It could reveal secrets about the birth of stars, the formation of galaxies, and even the origins of life itself. Moreover, it's not just about answering age-old questions. The study of Nitrogen-20 could also lead to practical applications. It could contribute to advancements in nuclear energy, environmental science, and even medicine. The potential is limitless, and that's what makes this research so crucial. As we stand on the precipice of discovery, it's important to remember that science is a journey, not a destination. Each answer we find leads to more questions, each discovery leads to more mysteries, and that's the beauty of it. The pursuit of knowledge is an endless endeavor, a quest that fuels our curiosity and drives our progress. As we delve deeper into the mystery of Nitrogen-20, who knows what secrets we'll uncover? Stay curious and keep exploring. Goodbye for now.